let's start to apply this. I copied our second fundamental theorem of calculus up here for reference. And now we're going to apply it. So I have the derivative of the integral from x to 0 of 2t minus 3 dt. Now I'm going to kind of label this as this equation has 4 parts. Let's use yellow. That'll look better. So what I'm going to do to start off is find each of these 4 parts. So step 1 is finding f of v, where v is my upper limit. So in this case, my upper limit is f of 0. So let's find f of 0. Here's my f. So 2 times 0 minus 3 is going to equal negative 3. So that's f of v, negative 3. Number 2 is v prime, where v is my upper limit. So the derivative of my upper limit, 0, is just 0. Step 3, I need to find f of u, where u is my lower limit. So this is going to be f of x, because x is my lower limit. So I'm just going to plug x in to get 2x minus 3. And step 4 is u prime, which is the derivative of my lower limit. So the derivative of x is 1. Now I'm going to do f of v times v prime. So negative 3 times 0 minus f of u times u prime. 2x minus 3 times 1. And now I can simplify. Negative 3 times 0 is 0, minus 2x minus 3 times 1 is just 2x minus 3. I would keep brackets on this so that you remember to distribute that negative to get negative 2x plus 3. And that's my answer. Let's try number 8. So let's do our 4 parts again. Let's do our first 2 first. So this first one is finding f of my upper limit. So my upper limit is 5. So this is going to be 2 times 5 minus 3, which is going to be 7. And then 2 is the derivative of my upper limit. So the derivative of 5 is going to be 0. Then I have my other 2 pieces where I'm going to plug the lower limit in. So f of 2. So 2 times 2 minus 3, which is going to be 1. And then the derivative of the lower limit, well, the derivative of 2 is just 0. And now we multiply and subtract them. So f of 5 times the derivative of the upper limit minus f of 2 times the derivative of the lower limit, which is going to be 0 minus 0, which is 0. Now, this answer of 0 should make some logical sense because this is a definite integral with numbers, which we learned from our last lesson. The answer to that is just going to be a number because I'm just taking the signed area from 2 to 5. And if I take the derivative of a number, that's going to be 0. Okay, let's try number... I am actually going to have you try number 9 on your own. When you're ready to check your answer, come back and see how you did. Okay, welcome back. Let's see how you did. Plug in the upper limit to my equation, so I get x cubed squared, which is x to the 6, plus 2x cubed. The derivative of the upper limit. Plug in the lower limit, so negative 1 squared plus 2 times negative 1, which would be 1 minus 2, so negative 1. And the derivative of the lower limit is 0. And now I times the first two minus times the second two. So this is all just going to be 0. So I moved my 3x squared in front just to make it look a little nicer, and that's what you should get. Okay, last one is number 10. This one's worded a little differently, but it's the same idea. F of x equals this, find f prime. So it's really saying take the derivative of this stuff. So it's the same process, the same 4 steps. So once again, I want you to pause the video, try this one out on your own, and then come back and see how you did. Welcome back. Check what you got with what I got. Now, while you're checking this and looking over your work if you got it wrong so you can figure out where you went wrong, just keep in mind that this is the process you will do anytime you're asked to take a derivative where the limits are equations. So anytime you need to take a derivative of an integral whose limits are equations, that's where you apply the second fundamental theorem of calculus. And okay, that's it for the second fundamental theorem of calculus. In the next video, we're going to talk about taking integrals of logarithms.